Greetings everyone, and today we are going to discuss about the bond energy. So here, what is a bond energy? We know that whenever a molecule is broken down into any compound. For suppose, let us take the example of oxygen. Oxygen molecule is broken down into two oxygen atoms. If it is broken down into two oxygen atom, then in order to break it up, it requires high amount of energy, which is the heat of reaction, to be absorbed by the oxygen molecule in order to break down into two individual oxygen atoms. In this case, the energy which is absorbed by the oxygen is the heat of reaction absorbed by the oxygen molecule. And in this type of reaction in which the heat of reaction is absorbed is known as endothermic reaction. Endothermic reaction. And for suppose on the contrary, if we are having two oxygen atoms, if you are having two oxygen atoms which are combined together, which are supposed to combine together or combine together in order to form an oxygen molecule, then high amount of heat of reaction is released from both of the oxygen atoms. And in this type of reaction, when heat of reaction is released, is known as exothermic reaction. In this case, when in endothermic reaction, the energy which is absorbed by oxygen molecule is positive. Why? Because energy is being absorbed inside the oxygen molecule. In the exothermic reaction, energy is negative. Why? Because the energy is being released from the oxygen atoms. Now coming to our point of bond energy, what is bond energy? Bond energy is the amount of energy which is required by 1 mole of molecule to be broken down into its components. The amount of energy required for 1 mole of molecule present in a given reactant sample to break down into its component. As we are having, for suppose, 1 mole of oxygen, it is supposed to break down into oxygen atoms. So this amount of energy will be known as the bond energy. Now bond energy of oxygen molecule to break down into uh, oxygen atoms is 495 kilojoule per mole, while the amount of energy which is required for oxygen, the amount of energy which is required, or we can say the amount of energy which is released when the oxygen atoms form a bond together to form oxygen molecule is minus 495, because the energy is being released, and the unit here is kilojoule per mole. Kilojoule per mole, which means that the amount of energy which is required to break down 1 mole of a molecule present in a given reactant, or one Avogadro's number molecule present in the given reactant. In this case, we are having some factors over which it depends. First includes the polarity. Now polarity is a factor which is dependent, which causes to increase or decrease the bond energy. Bond energy is also known as enthalpy energy, because here enthalpy, it is a measure of enthalpy at 297 Kelvin, and that is also known as enthalpy of atomization. Enthalpy of atomization, why is that so? Enthalpy of atomization refers to the enthalpy of enthalpy, it is referring to heat. Enthalpy of atomization, the amount of energy which is uh, required in order to break down the molecule into its component, is known as enthalpy of atomization. Enthalpy refers to the word heat. Atomization means breaking down into its component, into its further atoms. Now polarity is a factor here. Polarity is a factor which includes the condition that if there's polarity means two opposite poles, positive and negative, which means there should be an electronegative difference. And if the electronegative difference is higher, the forces of attraction between the two molecules is higher. As forces of attraction between the two molecules is higher, there is a stronger bond formed between them. As there's stronger bond formed between them, they require high amount of bond energy. Now that high amount of bond energy is required in order to break them. So if there is high amount of electronegative difference, there is high amount of bond energy. Example of a good example of this is hydrogen fluoride. As you can see in the diagram, um, I guess it's not mentioned. Is it mentioned? No, it's not mentioned. So here hydrogen fluoride is having bond energy. Hydrogen fluoride is having its bond energy as 536 kilojoule per mole. It is having its energy as 536 kilojoule per mole. But um, When it comes to hydrogen chloride, HCl, it is having its bond energy is 431 kilojoule per mole. Now, in this case, the polarity electronegative difference of chlorine is 1.9 and electronegative difference of chlorine is 0.9. So, due to the electronegative difference, you can see there is high amount of difference in the bond energy as well. Now, another factor which is contributing here is the multiple bonds. If there are multiple bonds, then there will be higher bond energy. For suppose we are having in this example, we are having carbon to carbon triple bond. Carbon to carbon triple bond and carbon to carbon single bond are having different energy. Carbon to carbon single bond and bond energy is 347. Carbon to carbon double bond 611. Carbon to carbon triple bond 837. So as the number of bonds are increased, the bond energy is increased. Rest, we are also having the factor of size. If the size of the atom is smaller, then the internuclear forces between them is stronger because the internuclear distance is shorter. The internuclear force between nucleus and the valence electron is stronger, due to which the atoms require high amount of energy in order to form bond. As they require high amount of energy to form a bond, they form a stronger bond, as well as they have high amount of bond energy. Examples of this is hydrogen. As you can see, hydrogen to hydrogen bond, single bond is 436 kilojoule per mole bond energy. When it comes to another compound, for suppose let's take the example of oxygen to oxygen bond. Oxygen to oxygen bond energy is 142 kilojoule per mole. Even though both of these are having, even though both of these are having the same atoms, they are having different bonding energy because of different size. Hydrogen is smaller in size, oxygen is larger in size, due to which their bond energy is decreased accordingly. That's all about this video. Hopefully we'll meet again in another one.